Hello everyone and welcome to today's webinar, No Sweat Nanoparticle Characterization with Stunner. I am Kaylee Bach of LabRoots and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Unchained Labs. To learn more, please visit unchainedlabs.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd now like to welcome our speaker, Nellis Dennis, Product Manager at Unchained Labs. Nellis, you may now begin your presentation.
Thank you for that introduction. Welcome to this webinar, No Sweat Nanoparticle Characterization on Stunner. Meet Stunner, an instrument with a unique combination of UV-Vis and DLS. Stunner has a variety of applications for proteins and nucleic acids, for AAV, and also for the topic for today, nanoparticles. I'm sure everyone knows the famous phrase, life is like a box of chocolates. You never know what you're gonna get, from the movie Forrest Gump. And he's right, without biting them open, there's really not a way to know what is inside. Nanoparticles are very similar. Once made, you know what you want to be in there, but it's difficult to know if it's actually present and what its concentration is, without breaking them down. There are a lot of properties that are important during development of nanoparticles. What particle shape you want and what size they should have, which lipids or other components will be used and in which ratios. Choosing your API payload, choosing potential surfactants, what charge the particle should have, in which buffer and which pH it should be in. Now once the particle is made, two important questions come up as well. What is my particle's payload concentration, and does it have the size I want it to have? Nanoparticle size is critical to the performance of a successful drug. So when you've got lots of buffers, formulations, and RNA constructs to test, you want to be gathering size data on everything. Nanoparticles are booming, and they come in a lot of different forms. Liposomes, lipid nanoparticles, solid lipid nanoparticles, lipid nanoemulsions, polymeric nanocarriers, and many, many more. Particles with their own unique tweak and proprietary content for many different applications. In gene therapy, for example, but also cancer treatment, vaccine development, and other biopharma. One of the reasons for this abundance of options is the fact that a variety of payloads can be encapsulated. Of course, making nanomedicine an option in a lot of areas. The payload can be RNA, DNA, protein, or practically any other active pharmaceutical ingredient. And then there is a range of options for each category. For example, for RNA, it can be different types, for example, like messenger RNA, but also small interfering RNA. Stunner tackles these two questions simultaneously. With our nanoparticle application, Stunner delivers low-volume, high-throughput DLS without the need for dilutions to get the size and PDI data you need. On the same 2 microliter sample, Stunner quantifies your total payload concentration, whether it's RNA, DNA, protein, or another API, without the need for any reagents, standard, or fluorescent dyes. All this is done in a 96-well plate-based format that powers high-throughput analysis of nanoparticle samples, fresh out of mixing. Now, Stunner contains 2 technologies to read each sample, UV-Vis for concentration and DLS for sizing. So simply add in 2 microliter of your nanoparticle sample into the input well, and it will be pulled into the microfluidic reservoir. At this step, the sample can sit for up to 2 hours before reading, with no evaporation. Now, after the plate is loaded into the instrument, the circuit is read first when it's empty, and that will remove any absorbance contribution from the plastic. And then a pump applies a small vacuum which moves the sample into the microcuvettes to be read. Because the circuit has fixed path lengths, it can make very precise and accurate measurements. Here we can see exactly what sample loading looks like with the help of some fluorescein and a blacklight. In 2 wells, we've already added 2 microliter of fluorescein. As you can see, to load another sample, you simply add in that 2 microliter into the input well and the sample wicks into the plate. On the left you can see those loaded samples, and on the right you can see the samples after being measured with Stunner. The two diamond shapes are the cuvettes for one sample. What this also shows is, after pumping, all the sample remains in your consumable, and so there's no contact between the samples and the actual pumping system. No contamination possible. LNP size is critical for the performance of a successful drug. Throw a stick in the literature and you'll hit a paper with LNP size data, often showing the link between size and the effective dose needed. Here we're looking at intensity distribution data for a whole plate of LNPs, with the average diameter noted as the value below each distribution. These mRNA LNPs had a hydrodynamic diameter of 79 nanometers plus or minus 1% and a PDI of 0.14 plus or minus 0.02. Stunner will provide DLS results just how you like it, with hydrodynamic diameter and PDI. But now, you no longer have to be limited by DLS data that has to be manually gathered for about a dozen pieces of data in a day. Now DLS can keep up with LNP samples as fast as you can make them, allowing you to run as many replicates as you want. Stunner's DLS gives you the high throughput power to gather the size and size distribution data on 96 samples in less than an hour. With just 10 minutes of hands-on time, Stunner will do all the rest in about 45 minutes, while other instruments will be one by one, resulting in more than 3 hours hands-on time to get DLS on those same 96 samples. Now let's focus in on the quant part, how to use Stunner to get the payload concentration of your nanoparticle. The most famous product with nanoparticles are for sure the latest mRNA vaccines. An important factor is of course the dose. Dye-based quantification or multi-step required dilutions use costly standards and dyes, requires hours of analysis and hands-on lab work, and includes breaking down the precious particle you just made. There needs to be a better way. And you could try to quant with UV-Vis, but nanoparticle solutions have tons of turbidity, so traditional UV-Vis approaches fail, until Stunner. Load up an LNP sample into a Stunner sample well, and you'll quickly see it being wicked into the serpentine reservoir and held there. To read the plate, Stunner will pump the sample into the 0.1 and 0.7 mm pad length microcuvettes for UV-Vis absorbance measurements. When reading LNPs, the combination of Stunner's two fixed pad length microcuvettes provides precision and a broad dynamic range. Since LNPs are typically very turbid, cloudy samples, the short pad lengths are needed so that light can pass through and enable absorbance measurements. Now let's take a look at some RNA LNP samples. The empty LNPs create a whole lot of signal that looks like absorbance, but it's actually turbidity, and it usually isn't helpful and just gets in the way. Because all that turbidity makes quantifying with traditional UV-Vis almost impossible, the total RNA quant by UV-Vis is normally a big challenge. For example, if we squint at the full curve, we can see the RNA bump at about 260 nanometers, but the difference is pretty small. To analyze this, we have to separate out the signal from the turbidity from the signal from the actual LNP absorbance due to RNA and other LNP components. On the left, we have the raw data again for our full LNPs. And on the right, Stunner has used our Unmix algorithms to isolate the impact of turbidity and remove it. This is shown by the black line indicating the total signal, and the gray line indicates the contribution from turbidity. The remainder is green and blue. Green is the isolated signal from RNA, and that will be our total RNA concentration. Blue is the UV-Vis absorbance signal from other components in our sample, UV absorbing lipids, excipients, and buffer components. Stunner separates the contribution of those three groups, turbidity, RNA, and other components, to quantify the total RNA concentration. This in less than a minute per sample from just 2 microliter, without any dyes, reagents, or complicated workflow. Stunner's RNA concentrations agree closely with the total mRNA concentration determined by Ruber-Green. The twofold dilution series of Firefly luciferase mRNA LNPs showed highly linear results down to 1.2 microgram per milliliter. Error bars are plus or minus 1 standard deviation. As mentioned, Stunner lets you run 96 samples in an hour. Here we can see 96 replicates of RNA-LNPs, where the green is the RNA concentration, and it's also mentioned below the graphs, and the gray is the turbidity signal. The coefficient of variation is a spectacular 1.54% over these 96 complicated samples. So quant exactly like you want. Using RiboGreen to quantify your RNA means you'll need to lyse your particles, use 2 standard curves with costly standards. Basically, to measure 4 samples, you'll end up measuring 96 samples, including all the standards and controls. While doing 4 samples on Stunner is simple, dye and standard free, no lysis needed. You'll get RNA concentration and size in about 4 minutes for those 4 samples. RNA-LNPs are of course not the only nanoparticles out there. As mentioned in the very start of this presentation, nanomedicines have a broad area of applications. So let's take a look at some other potential payloads. These next graphs show results from Stunner on either DNA LNPs or protein LNPs. Stunner applies those same algorithms to remove the turbidity signal so you can get an accurate DNA or protein concentration without dyes or breaking down your particle. And it doesn't stop there. Labs are making all kinds of nanoparticles, so Stunner allows you to customize its algorithms to look at the spectra. Simply tell Stunner what to look for and the software will do the rest. This is a combination of a protein and RNA in a nanoparticle. Stunner will unmix the turbidity signal and the protein and RNA signal to allow you to quantify whatever you want. Here you can easily get the protein concentration, but if you want to flip-flop and quantify RNA payload instead, that is no problem. With a click of a button, you'll get those results as well. And as mentioned a couple of times, nanomedicine is hot and new, unique and proprietary particles with their custom payload are developed rapidly. Teach Stunner all about the UV-Vis absorbance of your nanoparticle. Shown here is a setup in the software and the results, where Stunner allows you to create your own reference spectra, providing the possibility to set up your custom application and quantify exactly what you're interested in. And this is how it works for your unique particle. You've shown Stunner what your pure API is, and it will deconvolute it from the raw spectrum to get you the result you need. Skip the disruption step and quantify any payload, whether that's RNA, DNA, a protein, or whatever small molecule. Stunner makes quantification crazy simple to free you from complicated workflows, costly dyes, and wasteful standard curves. We also have IQ/OQ procedures available, and Stunner software is 21 CFR Part 11 compliant with full audit trail and electronic signature capabilities. And for labs doing manufacturing, quality assurance, and quality control, Stunner has a performance verification. These tests meet the United States Pharmacopoeia and the European Pharmacopoeia guidelines for UV-Vis spectrometers. The tests and all necessary calculations are handled automatically by the software. Stunner's nanoparticle applications combine both UV-Vis and DLS technologies on a single sample to deliver total payload quantification and low volume, size, and PDI results. So that is how Stunner delivers label-free, standard-free, and hassle-free gene therapy quantification. So always know exactly what you got in your chocolates without the need to bite in them first. Thank you for your attention. I'm happy to take any questions now.
Thank you, Nellis, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen, and we'll answer as many of your questions as we have time for. All right, let's get started. Our first question asks, I have a hybrid particle containing protein and DNA. Will that work?
Yes, no, that will work. So with the latest changes, you can teach Stunner what the absorbance of your specific DNA particle is and your protein particle, and Stunner will deconvolute those. Of course, you can also use preset DNA and preset protein spectra to do so. So it will not be a problem, and you'll get quantification like you want it.
Great, thank you. Our next question here asks, is it compatible with samples in ethanol?
Yeah, so yeah, normally fresh out of mixing, nanoparticles can contain a high amount of ethanol. Up to 20% ethanol will not be an issue. Above that, you'll need a little bit of buffer exchange first. If you're looking into, for example, automated buffer exchange, we also have a system for that, Big Tuna. But otherwise, everything below 20% ethanol shouldn't be an issue.
Great, thank you. All right, another question here asks, can this system be automated?
Yes, one of the great features about Stunner is our plate is SBS compatible, and so it can be pipetted with any liquid handler or a multi-channel pipette or anything like that. And we have a specific API setup, and so with any driver, liquid handler, anything can be integrated. So you can have a fully automated setup with Stunner.
Wonderful. All right, another question here asks, is a standard curve of some sort needed or blanking with an empty nanoparticle?
So no, that's one of the great things. You don't need any standard curve or anything like that. You don't need to blank with your empty nanoparticle. If you have normal, well, the default nanoparticles like we use the LNPs, you can just use the app as is. If you have absorbing nanoparticles, you'll need to teach Stunner a little bit, but then you don't need to blank or use a standard curve at all afterwards. So it's very easy and straightforward to use.
Great, and I want to thank our audience for these wonderful questions coming in. We have a few more here. Another one asks, how about quantifying the payload of viral particles like AAVs and lentiviral vectors?
So for viral particles, more specifically for AAV, we have a specific application for that. So it works a bit the same way. So we can deconvolute the protein and the single-stranded DNA. And actually, with that application, we can give you a full capsid titer, a total capsid titer, an empty-full ratio, and you can see aggregation information as well. So for AAV, that's very specific. On other viral vectors, you can still do that same deconvolution, but we don't have a specific application for that. But of course, it's worth testing out.
Great. And it looks like we have time for one more question here. And this last one asks or mentions that you have not touched on latex or magnetic NP. What can the Stunner do to analyze these types of samples?
So we don't have much experience with specific latex or magnetic nanoparticles, but as long as these absorb, it will definitely be possible, or at least that your payload absorbs. And I wouldn't suspect any issues. And so it could need some tweaking for the actual, if there's empty nanoparticle absorbance, we would need to adjust for that a bit, but after that, it should be fine. I would think, yeah, if you have those specific samples, we can always do a demo or anything like that. So.
Well, thank you again, Nellis, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Unchained Labs, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.